Good evening, everyone.
Good evening, sir.
Okay. Today we are assembled here to discuss about the topic, the microwave losses when it is propagating through the free space in a design thinking approach. So, as you know very well, we are studying the topics, all the topics in the design thinking manner, like covering all the 5 stages in our each and every topic. So, we are going to address this microwave losses. What are the losses will occur when the propagation takes place, that we are going to discuss over here. So as a people, you are studying the course in your current semester, you can also put forth your points in a design thinking manner, so that we can finally we can conclude what are the difficulties is there and how we can finally prototype it and test the components, everything we can discuss. Okay, so the forum is yours. You can share your points, your views about this topic in a design thinking manner. Yes, you can share.
So,
yes.
First, we all know that microwave engineering deals with high frequency signals, and transmission loss is a normal term usually when we propagate wave in the normal free spaces. So the traditional method includes just solving equations, but design thinking framework gives us a detailed structure on solving and giving an ideate and a prototype to minimize these losses. So in the empathy part, we know that the microwave engineers works on transmission losses which will be in normal gigahertz. So the stakeholders who are working in these fields are RF engineers, consumers like us, and then a few circuit design engineers. So normal transmission losses like dielectric losses, constant losses, and radiation losses includes in these areas.
Yeah, okay. As Nitin said, so it is a very high frequency range, right? So the actual scenario is it is invisible. The range will be with near to the infrared, so it is very difficult to handle. So these are the empathy. So empathy usually we will see we will consider everything. So all those things in the empathy part. So in a defined part, we will point out any one or any some few things which must be addressed actually. So that is the thing. So what is the defined part here?
So while coming to the defining stage, the core problem related to the transmission losses in the microwave systems are, which can be mismatched materials like impedance mismatch, and transmission lines which can occur in a small imperfections, and poor dielectric materials or some softy roughnesses in the areas, and transmission cable length which can be lead to higher transmission losses in this microwave systems. So it can be rectified into these losses by resolving the signal losses by engineering, which can be solved by our microwave engineers to perform a meaningful and beneficial transmission losses in the manner.
Yeah, it's correct. Then, so what is the as he said, we got the what is our problem, right? So now we need to have a different kind of a solution. From that, we have to take any one solution appropriately, right? So that's what is your idea for this?
So coming to the ideal part, as Nishant said, there are many forms of problems leading to transmission losses. So we need to create a prototype with improvements considering his points to the transmission losses. So we can create with there are different types of solving this problem. So the main idea is to replace the dielectric materials less tangent loss transmission loss dielectric material, and to shorten the transmission cable. So and the main important thing is to check with whether there is unusual impurities like unusual bending and unusual continuities with the transmission cables. So which set the ideal part. Moving to the prototype, so we can keep an example as transmission loss in a coaxial cable. So the prototype should be with less transmission loss dielectric cable, and shortened transmission cable. So what this does is it makes the system more reliable for industry purposes, and with the shortened transmission cable, so the area of transmission becomes higher, and the transmission loss directly reduces up to 30 to 35%.
Yes, as he said, so this is a prototype. So finally, we have to check the thing how it is happening really, the gain or power values. So those things should be measured from the such kind of a, appropriate oscilloscope like spectrum analyzer, network analyzer is there, right? So such kind of equipments which is available to check or test the equipments whether it is working properly or not, right? So thanks for the discussion, for the design thinking based concept analysis. Thank you.